So here's the final exam review. The first problem, please excuse my dear Aunt Sally. Let's remind you what that stands for. So P is parentheses, but it also includes any kind of grouping symbol like a bracket, a parenthesis, or a big fraction line. E stands for exponent, so if there's a power on something. M and D go together. That's multiply and divide. And you do that from left to right as it occurs in the problem. And then AS is for addition and subtraction. That goes together for left to right as you get to them. So there's really 1, 2, 3, 4 steps. So parentheses, exponents, multiply or divide, then add or subtract. So let's take a look at problem number 1. So we have that grouping symbols, those parentheses around them. So we have to go inside the parentheses and then follow order of operations again. The first thing I notice from our please excuse my dear Aunt Sally list would be the exponent, right? The 4 squared. So let's do that next. 4 squared, remember, is 4 times 4, which is 16. Now, inside the parentheses, you continue, please excuse my dear Aunt Sally, inside the parentheses until you're down to one individual number. So the next thing on our list would be division. 26 divided by 2 is 13. And then the only thing left in there is addition and subtraction. We're going to do that from left to right. Okay, so 13 plus 16 is 29. 29 minus 7 is 22. And then as soon as we're down to one individual number, you don't have to write the parentheses anymore. It's just going to be 22 divided by 11. So our answer is 2. Any questions about our first problem? Okay, let's move on. Now, number 2 technically is a please excuse my dear Aunt Sally problem, but you do have to use some rules of expressions and plugging in some values. So it says we want to find the value of that expression when x is negative 2 and y is 1. So every place you see x, we're going to put a parenthesis, we're going to pop in negative 2, and every place we see y, we're going to pop in a 1. Okay, so this x right here is going to become a negative 2. I could actually write here. And every place we see a y, we're going to put in a 1. Okay. So remember, we have to do parentheses or grouping things first. So this parenthesis already has a value in it, so it's okay. We'll just leave it there. Now this parenthesis we need to bring down to one particular number. So if you follow order of operations, this 3 next to the x or 3 next to the negative 2 means we're going to multiply. So that's going to be negative 6 plus 1. And then negative 6 plus 1 is negative 5. Now remember, the next thing we got to do are deal with the exponents. So negative 2 squared is negative 2 times negative 2, or 4. Negative 5 squared is negative 5 times negative 5, or positive 25. And then if we multiply them, the answer is 100. Okay. Any questions at all about number 2? Okay, let's move on to number 3. Now, here is where we're going to take a formula and we're going to do a little bit of rearranging. Okay, and so it says, using the following formula to find C when F is 95. So you might recognize this. This is the Fahrenheit to Celsius conversion sort of formula. So let's put 95 right here. And we just have to remember now it becomes just an equation that needs solved. Okay? So what do you think the first step we could do to get to the point where we're going to solve it? Yeah, get rid of that 32, right? Subtract 32 from both sides. So just to save room, 95 minus 32 is 63. Now that 9/5 is multiplying by the c, so we have to divide it. To divide by a fraction, the most efficient way to do it is to multiply by its reciprocal. So that's what I think we should do next. So what I'm going to do here is I'm going to multiply each side by the flip of 9/5, which is 5/9. So multiply both sides by the reciprocal is the same way as dividing a fraction off. Now let's think about why that happens. This becomes a 45 and the bottom becomes a 45, and so they cross out and it becomes a number 1. So that's why it cancels out. That's why we do that. Now over here I can give you a little trick of how to do this. This is 5 times 63 divided by 9. Now you can divide the 9 in first, which is probably the easiest thing to go. And then we get 5 times 7, or 35. So it's 95 degrees Fahrenheit is the same as 35 degrees Celsius. Anybody have any questions about number 3? Okay. Let's take a look at number 4. Now number 4, if you are finding missing lengths in a triangle, the first thing you want to determine is it a right triangle? Both of those are right triangles because they're going to mark it, or they have to tell you there's a 90-degree angle there. And so since it's marked, we're going to assume it's a right triangle. For right triangle side lengths, we can use the Pythagorean theorem. That might be something you want to write on your card. The Pythagorean theorem says that a squared plus b squared equals c squared. A and b, these are the legs of the right triangle, the things that make the L. Okay, those are considered your legs. They're the smaller two lengths in your right triangle. The c always has to be the hypotenuse. It's always going to be the side that is across from your 90-degree angle. It's always going to be your longest length. Okay? So as long as you remember that the legs have to be the A and the B, and the hypotenuse has to be the C, you're good to go. So let's take A and plop it into the formula. Well, the legs are 55 and 48. Now, it doesn't matter which you use as A or B. It doesn't matter. Just plop them in. Okay, so let's do 55 squared plus 48 squared, and that always has to be the hypotenuse squared. Now, before we go further, let's set up B. B, we are missing a leg, not a hypotenuse. So the setup looks a little different. This one is going to be 12 squared plus x squared has to equal our hypotenuse squared. So there is a difference in how you set it up, so please be aware of that. If it's a leg squared, you got to put a leg in the correct spot equals the hypotenuse squared. So let's actually finish up problem A. So let's actually physically square these two. Let's put some numbers right there. 55 squared is 3025. 48 squared is 2304. Now, since they're on the same side, we're going to add those two values together. So 2304 plus 3025 is 5,329. Now that's equal to x squared. Now how are we going to get that square off of there? We got a square root, right? Now remember, when you square root, technically we should put a plus or minus. But since this is a length, it's a positive, we don't have to worry about the plus or minus part. The square root is 73. Now, one really quick check to see that you were on the right track. If your hypotenuse ends up being the longest side, which it did, we got 73, which is bigger than 55 or 48, you're pretty much good to go, okay? Anybody have any questions about that one? Okay. Give you a second if you're still writing, and then we'll move on to B. Okay, let's move on to B. Now still, you want to do those actual 12 squared and 37 squared and put a number in that place. So 12 squared is 144. 37 squared is 1369. Now let's think about when we're solving an equation, you want to get that variable by itself. So that x squared is not alone. We need to move that 144, and we do that by subtracting 144 from both sides. And so 1369 minus 144 is 1225. Remember, we're going to get rid of that square by square rooting. Don't worry about the plus or minus for this one. And the answer is 35. Now remember, a good little check. That was a leg. That leg should be smaller than the hypotenuse. The hypotenuse was 37. My leg was 35. We're good to go. Okay, and especially since it worked out nice, you probably could assume, hey, it's probably okay. So remember, make sure you know your Pythagorean theorem and how to use it. That will be something that will be on the test. This I followed when I made the review. I made up the test first, and I made up the review following along with it. So if you can do this stuff, you're good. You're ready for the test. Okay. So there's number 4. Let's take a look at number 5. Number 5 is about distributing a monomial one piece into something else. So remember how that's going to work. We're just going to take the -2 and distribute it or multiply it by both things that's in there. So that's just -2x squared minus 10. Now make sure to distribute the negative and the 2. Both things go with it. Now for B, when we distribute the 2x squared, it's kind of the same procedure. We're going to take that 2x squared and distribute it. But please make sure what's going to happen. You're going to multiply by the 2. And exactly. Each one of the x's, we're going to add an exponent of 2. Because when the bases are like and you're multiplying, we add the exponents. So let's do that. So this is going to be 2x to the 5th. See how we added those exponents? Minus 4x to the 4th. We added those exponents. And then finally 8x squared. We didn't have any, so it just stays an x squared. So those are pretty straightforward. No, you don't have to go any further. You don't have to do anything. Just distribute and be done with it. Now, if it says factor, you're going to go the opposite way. But since it says distribute, just multiply it and be done with it. Let's take a look at number 6. Number 6 says to find the mean or the average. Remember the average, we're going to take the total and divide it by the number of items on our list. So it's total divided by the number of items on your list. That is your mean or your average. So if we look at the total, divided by the number on the list, we're going to add up 4 plus 6 plus 8 plus 8 plus 10, which is 36. Count the number of items on the list. We've got 1, 2, 3, 4, 5 things. We're going to divide by 5. And 36 divided by 5 is 7.2. Let's do the same thing for B. Just the total divided by however many items are on the list. So if we do 5 plus 5 plus 5 plus 9 plus 17 plus 20. we get 61. There are 1, 2, 3, 4, 5, 6 items on this list. 61 divided by 6 is 10.17, depending on how you round it. Much of the test is multiple choice, so you'll be able to see the way that I rounded on the test. Okay. Any questions about that one? Okay. Yes. Yeah. Yes. So I think that what I did is each one of the answers was I rounded to the same decimal place. So you'll be able to tell which one was correct. Yeah, I don't think I put the little bar over the 6. Even when I was writing it, I was debating, but I don't think I did. I think I rounded it. Yeah. Just easier when you're typing in a multiple choice thing. You good? Okay. Okay, now let's take a look at number 7. Number 7 says to translate and solve. So let's go. It says a number times 7 equals 14. So all they want there is some number times 7 equals 14. And you could have even also written 7x equals 14. Either one's going to get you the same thing. And then it's just solve that equation. What do we have to do to get x by itself? Yeah, get rid of that 7, right? So if we divide by 7, we get that x is equal to 2. Okay? Now let's look at 7b. It says the sum of a number and 7 is equal to 10. So a number plus 7 equals 10. As you can tell, I did not make these super weird translations. But and how do we solve this one? Yeah, we got to subtract 7 from both sides. Okay. So just some very simple translations. Remember, sum means addition, difference means subtraction, product means, as another way they could write multiplication. Just simple things like that. Now that kind of started out some equations. Now let's take a look at some more complicated equations. So let's look at 8a. Now, we're trying to solve for x. We can start out by distributing the 2 on the left side so that the x isn't trapped in a parenthesis anymore. That's a good way to get the parentheses off. So let's distribute the 2. We get 2x minus 4 equals 8. Now, what's the next step we're going to take to solve that equation? We're going to get rid of that 4. We're going to add 4 to both sides. We're going to get 2x equals 12. And then how are we going to get rid of the 2? You got it. Divide by 2. Now remember, you could stick that value of 6 into the original. And if it makes a true statement, if it equals 8 when you stick it in, then you know you did it right. You can see 6 minus 2 would be 4. 2 times 4 is 8. I mean, it's a quick check. It is multiple choice, so if you get stuck on the front ways, try it backwards. Try sticking it into the equation and go from there. Let's take a look at B. First step for that one, what do you think it would be for that one? Yep, get that 14. So the 10 is attached to the x until we divide it off. You don't want to divide it off until it's ready. So move that 14 first. So we're going to add 14 to both sides. We get 10x equals 10. Divide by 10. X is equal to 1. So like I said, pretty straightforward. I didn't make the equations or anything super crazy. I just wanted you to demonstrate how to solve a basic equation. Now, the most complicated ones will look like ones like 9. So what I would like to do first is the fractional one, and then we'll move on ones where we have a little bit more junk to it. In 9a, there's a mixture of ways you can do that. If you're really good with fractions, you can keep them fractions. Many people don't like fractions, so I'm going to remind you of a trick. If you have a rational equation like this that has fractions contained in it, what you can do is a little trick. You can multiply everything by the common denominator of the fractions. So if I have fractions with a bottom of 3 and a bottom of 2, what would that common denominator be? 6. So a really neat trick happens if I multiply everything through by 6. Now really that's technically 6 over 1. So the 6 only pops to the tops of these and just multiplies by that one. Okay? So this would end up being 6x over 3. Excuse me, the 3 that's in the bottom would end up dividing into the 6, right? So 6 times x is 6x, divided by 3 is 2x. Now let's do the same thing for this second piece. That would really end up being 6x over 2. Well, what is 6x divided by 2? Well, 2 goes into 6 how many times? 3. So that would be 3x. And then 6 times 10 is just 6 times 10. 60. Now you can tell I didn't do much, but that one step makes the equation look a lot just easier in general. So 2x plus 3x is 5x. 5x equals 60, divide by 5, x equals 12. So it starts out looking really gross, but by multiplying through by that common denominator, it usually really accomplishes a lot very quickly. Yes? Yeah. Let's take a look at 9b. Now, this one is a little more complicated because we have x's in a variety of places. So let's see what we can do as a trick to help us. Earlier, we had some problems with the distributive property, and this was a good time to use that distributive. Let's take this 3, and let's distribute it. Now, the 2x isn't changed, but we're just going to take the 3 and multiply it. So we're going to get 3x. Sorry, my Apple pencil's being a little weird here. And now, the 2x and the 3x, since they're on the same side, we can combine them. So let's combine them. And now it looks very similar to one of the problems we saw in 8. So, to keep going, let's move the 6 by adding 6 to both sides. And then divide by 5. Now remember, we got an answer of 2. If we put a 2 back into the equation where all the x's sit, we should get a value of 4 once we simplify. Okay, so you can solve those. Any questions there? Okay, let's keep going. Remember, you're going to turn this in after the end of the class. Okay, number 10. Now, I'm going to give you an equation that you need to rearrange and solve for a particular variable. So on your paper, you might want to make that the thing you're solving for like darker, a different color, something that it really kind of focuses your brain that x is the thing I want. Now the 2 and the y are multiplied currently by the x. When they're touching them like that, that's a multiplication. So the opposite of that is what you have to do. You've got to divide. So we're going to divide off the 2, but we're also going to divide off the y. Now, if on this side that fraction can reduce, like if there's a 2 somehow you can reduce, or the y you can reduce them. But on the right side, the 2's and the y's cancel out. That's what we want. So you just have x equals a divided by 2y. And that's all it is. Okay? So I will give you an equation and expect you to solve for a different variable than it originally has. Now, earlier in the year, we had done absolute value equations. So there are some absolute value equations on it, like number 11. The thing I want to remind you is that there are two possible solutions to that. Remember, an absolute value is a distance. So we want to know, okay, we could have a distance in the positive direction, or we could have a distance of 9 in the negative direction. So what you want to do is you want to rewrite it once, just drop the absolute values, write the word or, rewrite it again, drop the absolute values, but this time make the 9 a negative 9. So I call it case 1. It's a positive case. Drop everything, the absolute values off and just solve it. Case 2 is the negative case. We are going to drop the absolute values away, but make that negative case come up, okay? So that's the main key when you're solving these, is to set up the two cases. Set up the two cases. So think of it as 2x minus 3 is the distance of 9 away on the number line. So I could go 9 in the positive direction or 9 in the negative direction. So absolute value represents a distance, and so I can go either direction to get there. So the 2x minus 3 kind of stays fixed, and then the 9 represents that distance. So you go into positive or negative there. Okay, so now let's solve. Both cases, we're going to add 3 and then divide off the 2. So the first answer is 6 when we add 3 and divide by 2. The second answer, it's going to look different because now we're adding to a negative 9. So it becomes negative 6, and when we divide by 2, we get negative 3. So remember, two cases when you have an absolute value. Everybody okay with those ones? Okay. Let's take a look at number 12. 12 are our inequalities. The main thing to remember about an inequality is if it kind of acts just like an equation, you solve it the same way. But if you have to divide by a negative or multiply by a negative, you got to flip the symbol. That's the main thing to remember about those. Let's go ahead and start with 12a. Well, let's do b. It's easier. Let's start with the easy one, and then we'll go back to a. For 12b, just add 7 to both sides. Addition and subtraction doesn't change your symbol, just let your symbol alone. We solved it. X is greater than 17. Let me remind you about the graphing of it. Put your 17 down and maybe one number above it, one number below it, number line order. Now, let me make that look a little better than that. Now, if it has the equal to, we're going to use a closed-in dot. Doesn't have an equal to, remember, open circle. So we're going to put open circle on 17. See how this shape is on this arrow? I can remind you that where you're going to head to. We're going to shade to the right. Greater than goes to the right. Less than goes to the left. Now let's do the same exact thing for 12a. So the x on the left is already alone. So let's move the 4x over to join it. So let's subtract 4x from both sides. Now, at this point, we're going to need to get rid of the negative 2 to divide it off. Remember, when you're solving an inequality, if you turn it turn the symbol. Or if you multiply or divide by negative, you've got to turn the symbol. So we're going to divide by -2. But as a little reminder to my brain, because I'm somewhat forgetful, I'm going to circle that symbol to remind me that the next time I write it, got to flip it. So if you multiply or divide by negative, got to flip the symbol. So I get x is greater than or equal to 3. So let's remind you how to graph it. Put your 3 down, 1 below it, 1 above it. This time, the 3 gets a closed-in circle because of the equal to. We're still going to shade greater than, so it does go to the right as well. Any questions at all about our inequalities? Okay. Let's talk about domain and range and functions. The domain are the set of x's. If any of them repeat, don't worry about it. Just make the list. I tend to make the list least to greatest order, but just write down the list. The range are the set of y's. And if it's a function, the x's can't repeat. So those are just the rules. Okay, so let me remind you again. The domain is the set of x's. The range is the set of y's. It will be a function if the x's don't repeat. Okay, now we've said all that. Let's take a look at our x's. So the domain will have the x values of -2, 2, and 3. You'll notice that the 3 repeated itself 2 times. You don't write it twice. It's just, hey, what's in your x? What are the x values you used? So if it repeats, don't matter. You just write it down. Yeah, that's going to change. Now, the range are just the set of y's. So the set of y's, it's -6, 4, 7, 8. And order doesn't really matter. I do tend to write them least to greatest just so I can organize it and so I know what have I used, what have I not used, stuff like that. Now, remember the question about is it a function just asks, do any of the x's repeat themselves? Did we have an x that repeated itself? Look at the x's right here. We had an x that repeated itself. The 3 repeated itself, so that would be a no. It's not a function. If the x's are all distinctly different, it would be yes, it is a function. Now, for 14, we need to practice actually using a function, yes. So let's actually practice using a function. So I have 2 different things we're going to find. We're going to find f of 2 and f of a. Now remember how a function works. In this function, we are inputting an x. We're going to take the negative of x squared plus 2 times x minus 7. That's just what that function does. We stick in the x, that's what it does. Now let's stick in a 2. So wherever we see an x, the way that you want to think about it is put a little open parenthesis, and that's where your new input goes. So the 2, it is a replacement for the original input of x. Now you have to follow order of operations, so the rules we did in the very first problem don't go away. They continue, and they show up here. So we're going to get -4 plus 4 minus 7. Now we can do that Negative 4 plus 4 is 0. 0 minus 7 is negative 6. Now, one like 14b, we're just swapping out x's for a's. There is no difference. So just take out the x's and replace it with an a. Now, if it was more complicated than a, if it was like a plus 1 or a minus 1 or a plus h or something like that, I would actually physically use that parenthesis rule. But since it's just a variable, it's just going to take out one variable and replace it with another. And you can't do anything else. It is what it is. Let's take a look at 14. Now 14, I've given you a linear equation. Remember, linear equations can be ax plus by equals c, or y equals mx plus b. Those both represent a line, a linear equation. This one just happens to be in standard form. Now the question is, what is the x-intercept? What is the y-intercept? And what is the slope? Well, the x-intercept is where y equals 0, and the y-intercept is where x equals 0. So you're just going to take out either the x or y and make it 0 and solve. Well, the first one's pretty easy. If we let y equal 0, this right here is going to go away. It's going to become 0. So we just get 3x equals 12, or x equals 4. So I like x and y intercepts if it's in standard form. It's pretty nice, because you just take out the y, make it 0, so the y term goes away. In part B, we're going to take out the x term, because now this is going to become 0. And so we're just going to get negative 2y equals 12. Okay? So for the x-intercept, we're going to make y equals 0. For the y-intercept, we're going to make x equals 0, and we're going to solve. Yep. So in the x-intercept one, we divide it by 3. For the y-intercept one, we have to divide off negative 2 and get negative 6. Okay. What's great about intercepts like this is if we were asked to graph the line, we know we hit the x-axis at 4 and the y-axis at negative 6, and you can graph the line if you just know those and those points alone. So that makes things really nice as far as graphing. As far as the slope goes, you might want to write down on your card the equation y equals mx plus b. The slope is Rm. Now there's a way you can use the x or y intercept, but I'm not going to worry about that. I'm just going to rearrange the original to make it y equals mx plus b. The slope will stare us right in the face, okay? So let's take our original equation and solve it so it looks like y equals mx plus b. Let's solve it for y. So let's move the x. Let's subtract the x to the other side. I put it first because that we're used to the x coming first. So I put the x first. It becomes a negative when it moves to the other side. And then we just have to divide everything through by negative 2. And so we get y equals 3 over 2x minus 6. Now look what happened. We found the y-intercept was negative 6, so it should be a negative 6 there. Those two things, you should see that repeat happen because that's your b. And we find our slope is 3 over 2. So the slope of this equation is 3 over 2. Go back up to this line, this drawing. Isn't slope rise over run? You can see it's a positive slope. It's going upward from left to right. And look what we went. Up 6 over 4. 6 over 4 is 3 over 2 as well. So there's lots of information that you know about how a line works. Y equals mx plus b, slope, rise over run, all that stuff. So if one way isn't working in your brain, try try it the other way. You'll get 3 over 2 no matter what, okay? So there is 14. Okay. Let's go through 15. 15 says to find the line through, and I could have even said the equation of the line, through negative 2, 1 with a slope of negative 2. So I think the most effective way to do this, and I've given you this equation earlier in the year, is the point slope formula. Point slope formula. Let me give you that. If you know a point and a slope and you want the equation of a line, this is all you need. We're going to plop into this really great formula. Y minus y1 equals m times x minus x1. That's the point slope formula. In the slope spot, we're going to put negative 2. That's our m. In the point location, right here and here, we're going to put the point they give us. So the point is going to be negative 2, negative 1. The slope is going to be negative 2. Now, when you put a negative into the formula, the negative that's already there, that means the opposite of what it's showing. The negative of something is the opposite of it. Okay, so remember that. So we're going to do, this is going to be y minus a negative 1, so that's going to become plus 1, equals negative 2 times x minus a negative 2, which is going to become a plus 2. Now, most of the time when they ask you to find the equation of a line, yes, that's the equation. But they don't want to keep it like that. They're going to want it to be y equals mx plus b. They're going to want it to look prettier. So let's just practice that last few steps. So let's distribute the negative 2. We get y plus 1 equals negative 2x minus 4. And then let's subtract 1 from both sides to get y equals negative 2x minus 5. We should see the slope of negative 2 sitting right there, because that's your y equals mx plus b. So if you don't know that, if you didn't memorize that formula, that's a good addition to your note card for the test. Yeah, I would probably put the point slope formula, maybe y equals mx plus b. And that's the point slope formula for an equation of a line. Okay, let's look at 16. 16 says we have an equation of a line, y equals 2x plus 4. Okay, so what do we know? Yep. If y equals mx plus b, the m is your slope, the b is your y-intercept. So in this particular line, the slope is that 2 that we see right there. So when they ask for the slope, it's just 2. Now, if they wanted to know, well, what would the slope be for all parallel lines to that equation? Well, you might recall that the slope of parallel lines is the same. So it's just going to be 2. Now, if they want perpendicular lines, you might recall that perpendicular lines have slopes that are opposite signs and reciprocals. When you multiply them, you should get negative 1. So what we have to do here is we got to flip it and change its sign. So since it was positive, it becomes a negative. Now, how could you check it? Well, if you multiply if you multiply 2 times negative 1/2, you should always get negative 1. Slopes are always perpendicular if when you multiply them, you get negative 1. That's a quick little check. And since positive 2 times negative 1/2 is negative 1, that's just a really good way to go, oh yeah, they work. Okay. So parallel lines, the slopes are the same, perpendicular, they're opposite signs and reciprocals. They're flip it and change the sign. Exactly, that's correct. So there's 16. Now let's jump to 17. Now 17, what we're going to do is we're going to go a little further than the question before it. In 16, it says, well, what are these slopes that are parallel and perpendicular? Here it says we want an equation through 1, 5 that is parallel to y equals 3x minus 6. Well, what do we know? Well, the slope has to be 3. The point has to be 1, 5. Well, this is where that point slope formula, y minus y1 equals n times x minus x1, can work for us one more time. We can take the 3 and the 1, 5 and plop it in, do a little bit of algebra, we got it. So let's do that. Where the y1 sits, we're going to put a 5. The m is a 3. Where the x1 sits, we're going to put a 1. Now that's all well and good. It's just not pretty yet. You know, you just got to make it a little nicer. So the first thing I want you to do is distribute that 3. Okay. So we get y minus 5 equals 3x minus 3. And then that 5 needs to move, and so we just do that by adding 5 to both sides. So the equation would be y equals 3x minus 8. Oh, yes, there would be. I can do calculus, but I do weird things when it comes to addition and subtraction. Those are always the weird mistakes I make. There we go. Thank you. Okay. So any questions about 17? We're almost done. We only have a few more to go. Okay. Yeah. Oh, yeah. If you write on paper, you can always do that. Yes. Yeah. Yeah. If you write, some people just don't like writing on the iPad, so yeah. If you write it out on paper, go for it. I never mind. I like the feel of writing on paper, but iPads are okay as long as you have a good pencil. These are 20 or 25. Yeah, I didn't make it a lot. Yeah, no. Yeah, it follows it really close. Yeah, that's why I think, you know how it had a few parts. That's why I'm thinking it might be 25, because each part is its own thing on the test. Oh yeah, I didn't make it crazy. This has been a crazy year for me. Are you good? Let's take a look at solving a system. It says solve for x and y. Remember, to solve a system, if I've been kind to you, which I think I might have been, if the x's and y's are lined up, then the equals are lined up, and the numbers are lined up, I would suggest using elimination. Since the y's are opposites, that means that we can just add the two equations together. If they're not opposites, multiply them by the correct multiple to make them opposites, and then do the same thing. So like, you know, say that we wanted to make these the opposites. I would multiply this by -2, and that would be an opposite. Okay, so it just happened that y's were opposites. Let's add the equations together. We get 3x equals, because this would go away, 9. Now it just becomes a standard equation. Now remember when I gave you this on your on whatever test this was on, some of you stopped there. You need a point that they have in common, because these are two lines and we're looking where the lines intersect. So you have to still plug that back in. Now it doesn't matter which equation you choose. You can choose the top or bottom. It doesn't matter. Just pick an equation where x is sitting. Let's put a 3. Let's put it into this top equation. We get 3 plus y equals 7. Subtract 3, y equals 4. So the answer is a point. The point 3, 4. Yeah. Okay. Oh, I lied to you because there's so many pieces and parts. It's 33 questions on the test, but there's 3 points each, and you have it like an hour and a half to do it. Okay. Sometimes it's better to have a few more questions so they're not worth so many each question. Okay, so let's look at 19. So 19 is just a simple multiplying two monomials. So just remember, when the bases are alike and you're multiplying, you add the exponents. If the bases are alike and you're dividing, you're going to subtract the exponents. So we're just going to do a negative times a positive is a negative. 2 times 3 is 6. Now the x's, we're going to add those exponents. If you don't see an exponent, it's not a bad idea to write a little 1 on your paper so you don't forget to add that 1 on there. So 2 plus 1, that gives me 3 x's. And then the y, same thing. 2 plus 1 is 3. Yes, yes. Since there are just two terms, you can just multiply and mush them together. Now, B is kind of the same idea, except remember, if the bases are alike and you're dividing, subtract the exponents. Still not a bad idea to put the little 1 right there. Okay. Now, reduce 4 and 6 like you would a fraction. 4 and 6 are both divisible by 2. If I divide this by 2, I get 2. Divide this by 2, get 3. Now let's look at our x's. Where do we have more x's, top or bottom? Yeah. So we're going to subtract that 1x from the top, and then there's going to be 1x on the top. But where is there more y's, top or bottom? The bottom this time. So yes, we still subtract them, but this time the extra 1 is down in the bottom. So just be careful with that. I think that's the easiest way to do it. And so then left on top is a 2 and an x. On the bottom is a 3 and a y. Yes, yes. For a division over 1, just find the difference between the x's on top and bottom. And if there's no x's in the bottom, you would just leave the x's where it was and just leave it there. Yeah. Now, for 19, that multiplication does require distribution. So let's distribute the 2x. We get 2x squared minus 4xy. So take the first piece and distribute it. Now we're going to take the second piece and distribute it. So when we distribute the y, we get positive xy minus 2y squared. Now at this spot, I always check to see, are there any like terms, and we know they're like terms if they have the same variables with the same powers. These two are both xy's. So we can keep the xy's and just add or subtract the coefficient. So what is negative 4 plus 1? Negative 3. So leave that 2x squared, then we have negative 3 of these guys, and leave that negative 2y squared. Now, for part D, I am going to remind you, those are scientific notation. These x's are not x's, they're actual multiplication. That's just the standard. They put a little x between them. So it's just multiplication. I think the best way to do it first is to multiply the 2.4 and the 3, make that a number. That is 2.4 times 3 is 7.2. And then the 10s are, the bases are alike and you're multiplying. So,
can I have your attention, please? Will the following Southington students please report to the Dean's office? Jack Cabot, Cheeto Torres, Kobe Cernuto, Jared Anderson,
that's a good name.
Nick Dan. Those Southington students, please report to the Dean's office. Thank you.
If the front number happens to be more than 10, so 11.8, 9 point, or 19 point something, you do have to adjust your decimal point. Since this one is still a number between 1 and 10, it is in the correct form, so just leave it.
So higher than 10, you can adjust it.
Yeah, so let's say you get to the point where you get 204 times 10 to the fifth. Since technically your decimal point should be here, it should always be a number in front that's between 1 and 10. So that's 2.04. How many places did I just adjust it? 2 more. So we add 2 more on to the 7, or to the 5, making it 7. So that's what I mean if you have to adjust it. So the standard is in scientific notation, the front number should be any number between 1 and 10. It's allowed to be equal to 1. It's not allowed to be equal to 10. If it becomes a 10, you shift the decimal and make it a 1 again. Okay. Okay. Last question. Now, it has a few parts to it, but we are almost done. This is the last thing you gotta listen to me do. I know that you're gonna miss my videos so much, or my lessons. You're gonna watch them over the summer. I understand. I know how it is. Okay, so let's take a look at 20A. Now, if we are adding polynomials, you can kind of ignore the parentheses or drop them away and combine like terms. So x squared plus x squared, we got 2 of those. 2x plus minus 3x is negative 1x. And if you write negative 1, that's fine. It's not customary to write the 1. I don't care. And then finally, 6 plus 4 is 10. I'm not wanting you to try to factor the final answer or do anything funky to it. I just want you to add it. Now, there are... No, I didn't put any factor.
Oh.
I thought about it, but I was yeah, okay.
Oh, yeah. I like factoring when it's simple, not when it's insane.
Maybe I'll throw a bonus on there that's factoring. How about that? Did I put a bonus that's factoring?
No guarantee I'm a kid.
Okay, so let's look at this second one. If it's a subtraction, you must distribute the negative first, and then we can do exactly what we did in 20A. So this first is just x squared minus 4, but the back piece becomes negative 2x squared plus 3x minus 5. So distribute the negative first before you combine like terms, okay? So the x squared minus 2x squared is negative 1x squared. The next is 3x, which is, I don't know, it's the only thing there that's like that. And then negative 4 and negative 5 combine to give us negative 10. Okay. Say that again. So we had a positive 1 and a negative 2. 1 minus 2 became the negative 1 in front. Yeah. No, that's okay. Now, C, do you guys remember synthetic division a little bit maybe? Okay. Let's do C, division by synthetic division. So, remember how to do it. The first thing you want to do is set the bottom equal to 0 and solve that for x. So we get negative 1. Put negative 1 in the corner of our synthetic division box. Now let's look at our numbers. Our numbers are 2, 1, and negative 1. So we're going to write those coefficients down. 2, 1, and negative 1. We're going to put a bar between the last two numbers that are like 3 rows long. And we're going to make that a plus. And then whatever this number is comes down. Now that's just to set up the box. That's the way we always set up the box. There you go. Okay. Now let me remind you how it works. We're going to multiply, write it right here, and then add them up. So if we multiply, we get negative 2. Write it down. Add them up. Do it again. Multiply, write it down, add them up. Now this is my remainder. This is my answer. But my answer, the x's disappeared, so I got to put the x's back in. The number that's in the box, yes. Okay. So this was an x squared. Think of that arrow as not only bringing the 2 down, but it brought the power down. So now this is just an x. So the answer is 2x minus 1. The answer is 2x minus 1.
Oh, we might plug it in.
Yeah, negative times the negative made a positive. Yeah. Okay, let's look at D. Now, if things are not, yes.
How do you get the exponents to 2? Like in final?
So the power that was originally there was an x squared. The power now goes down 1 power. So 2 minus 1 is 1 again. So this was an x squared. It becomes an x. And then it just goes down the list. So, if it was an x cubed, it would go down to x squared. The next one would be an x, and the next one would be a number. Makes sense? Okay. So let's look at part D here. Now, if it is not a perfect square, like this one is not perfect, I can write down the perfect squares that are in there. Okay. The perfect squares that are in there are a 9 can come out. 2 of the x's can come out. And all of the 4 y's can come out. So, if I take the square root of the things that do work, the 9 becomes a 3, the x squared becomes x to the first, the y to the fourth becomes a y squared. So remember, a square root cuts the powers in half, takes the square root of the numbers. Well, what's left in there? Well, I had a 2 in there that I couldn't use. I had an x in there that I couldn't use. E. That is a one that needs rationalized. We're going to multiply top and bottom by the matching square root, and then it actually becomes a pretty nice problem. It's not too bad. On top, I don't know what that is, so it's just 10 times the square root of 2. Huh?
I said that was it for you.
Yeah, that's perfect. Now, on the bottom, square root of 2 times square root of 2 is square root of 4. What does that become? A 2. That's what we wanted. We wanted the radical to pop off. So it pops off and leaves a normal radical 2 on top. When you rationalize, it pops off the radical on the bottom and leaves a radical 2 on the top. And so then if you can divide, what is 10 divided by 2? 5. So you can just divide it. And so our final answer is 5 square root of 2. Okay. Last 2 problems. Now these ones have to do with the i's. Remember the i's? Thing you remember that you might want to put on your card is that I squared equals -1. That's a good little piece of information. Most of the time, i's are going to act like just a variable if it was an x or a y or a z. But if you get a power on there, especially a squared, you should make it -1. Okay? So at first, we just treat it like any other variable. Let's distribute. So we're going to distribute the 4. That's 12 minus 4i. And then we're going to distribute the I. So that's 3i minus I squared. Now, here's the problem. I told you that I squared was equal to -1. So we should take out that and make it a -1. So when we do that, we get 12 minus 4i plus 3i. And the negative in front of the -1 is going to make that a +1. And then let's combine any like terms that we've got. 12 and 1 is 13. -4i plus 3i is -1i. So there is F. Last problem. I know it's so sad, but let's take a look at this last one. Anybody in here taking the pre-calc next year? I'll get to put up with you guys again. You're not done with me, most likely. You gotta. But we can have a normal class with no masks and stuff, huh? I usually don't teach that. Now my schedule changes a little bit every year. Normally I teach pre-calc and calculus, or I haven't taught algebra 2 in like 10 years. Okay, so let's take a look at this one. So the 2 plus I and the 2 minus I, see, didn't you guys luck out? See, normal year, you wouldn't have. So we're going to multiply by the conjugate of the bottom. So the conjugate, you might recall, A plus B, the conjugate is A minus B. So we're going to multiply, not by that, 2 by 2 plus I on top and bottom. You always do the conjugate of the bottom. The conjugate of the bottom. Now, the technique we did in F is the exact technique we're going to do in G. Nothing different. We're going to distribute all the stuff on top, distribute all the stuff on the bottom, reduce it, we're good. Okay, let's do it. When we distribute on top, we get 4 plus 2i plus 2i plus I squared. On the bottom, we get 4 plus 2i minus 2i minus I squared. Now what do each of the I squareds become? -1. So that's going to become -1. That's going to become -1. Okay. So on top, we're going to end up with 4 plus 2i plus 2i minus 1. On the bottom, we're going to get 4 plus 2i minus 2i plus 1. Okay. Now, almost always with these, there's like terms now, we can mush them together. So at this point, let's mush our like terms together. So 4 minus 1 is 3, 2i and 2i is 4i. On the bottom, look what happens. Now, this is the beauty of why a conjugate is used. A conjugate is used because we do not want i's to be left in the denominator. So this -2i and +2i cancel each other out. So we're just left with a 5. And that's what we wanted to happen, to make sure that it became a correct complex number. Now the 5, sometimes I've seen it written like 3/5 plus 4/5 I, but they just take the 5 and put it under each individually, but it doesn't matter. I mean, this is correct. Now, if for some reason these were both divisible by 5, like one was 15 and one was 10, you should divide it. But if they're not divisible by 5, just leave it. That's your answer. Okay? That is it. Isn't that magical? Isn't that wonderful? Any questions? Yeah. Sure. Yeah. Okay. So, for problem D, you were looking for the largest perfect square that's in the number 18. Okay, so 18, the only perfect square that's divisible into 18 is 9, because I can take the square root of 9. So I rewrite root 18 as 9 times 2. And then since x cubed, 3 is not divisible by 2, I split it up. Here's my total of my x's. I have 2 of them and 1 of them, so I do have 3 of them. I just took one off so I could see what's happening. And then all the ones I highlighted in yellow, I could take the square root of. So 3xy squared. And then see how the ones I didn't highlight are the ones that are stuck in there. I would break it apart to find, yes. take out everything you can, and then the other junk just stays back for the ride. And then for E, you know how we use the conjugate for the i's? Well, we use conjugates for square roots. But if it's a square root of 2, just multiply top and bottom by square root of 2. If it's a square root of 3, multiply by square root of 3. And then things will settle down nicely by the end. Okay. Any other questions? Okay. So the test looks very similar to this. It's not super hard. Feel free to put whatever you want on the card. Any of those formulas to do with lines or whatever you need on the card. Your test is Wednesday. Okay? Wednesday, it's going to be great. And that's